Hey guys, today lecture 15. We learned a little bit about inductor, right? So we will do a quick review about inductor. So let's move on. First of all, I said inductor is, inertia component, right? So let's explain. So inertia, inductor, we have to memorize first of all inertia component. It's coil, it belongs here, and inertia means it comes off this way, right? And as I mentioned, it doesn't wanna sharp change, right? It make it smoothly. So let's move on. So as I indicated here, inductor do not change their current, instantaneously, like a sharper speed. They make it smoothly. That's why the arcs, happened. And I already made it this lecture, right? And another example is a smoothing reactor also we're using. And then, yeah, in the, DC circuit, in the steady state, inductors gotta be the shortest circuit. Like, for example, let's move on. I'll show you. So first of all, we have to memorize this equation. V, D, L, dt, d, I, t. Have to memorize. This, explain the inductor's, property. So if I make a circuit, this is circuit here. Switching, R, L. So if I switch in, turn and off, always transient state happen, then steady state. But in the steady state, if I see here, this slope, you guys can see this slope. Yeah, I will make it blue, more easy. So in the steady state, the slope is almost, flat. But in transient state, the slope is changed, right? So what I said is in the DC circuit, in the steady state, the else doesn't work because as you can see here, time goes by. If the I is changed, the voltage is induced, right? But here, the I is same here, current, for example, 10 ampere, right? So that's why only in transient state, it works. And as I said, in the RL circuit, if we switch on and off, it's automatically happened, asymmetrical, waveforms happened because of the inductor's property, right? And then this is also same. Look at that. So we say in inductor, we say it's a lagging current, right? Because look at that. It's a in math, I will explain a little bit. So Vt, dt, di, t. If we do differential, so I max sine omega t. And if we do a differential, I max cosine omega t, omega, multiply omega. This is when you do differential, right? So which means, look at that here. If it's sine, if we differential, cosine here, right? So as you guys can see here, the voltage is, lead and current is lagging in the else RL circuit. Yeah. And let's move on. And this part I will also explain to you guys. Yeah. So in our RL circuit, we say inductive reactance, right? As I said, X is a reactance, right? In AC, right? In AC circuit, we say impedance R plus JX, right? So now in the I'll explain in only L, only X has, right? And this is omega L. Omega also we could change it to pi F. F is hertz frequency, right? So which means if the okay, what I mean is okay. This is AC, and if it's 60 hertz, and this red color is 120 hertz, double. But check it here. The red is slope is quite sharp, right? Compared to the 60 hertz. 60 hertz is like, yeah, 60 hertz is this one. Firstly, I draw. And the second one, the 120 hertz is like this, more sharp, right? Compared to. So which means if the more, high hertz, which means reactance is more gonna be up, which means proportional. And in the coil, as I said, as you guys can remember, it's a store energy, right? It's a unit is J, joule. So this is equation. You don't need to memorize this. So which means in inductor, they store the energy in a magnetic field, right? Yeah, that's it. Today's quick review about the inductor. Yeah, actually, there's many more, but what I mean is at least we need to memorize this part. That's it. Today's lecture.